Greetings. This is the recording for feedback for week 5 quiz for Program Eval. And I just got through looking over the answers that you and the responses that you gave. And overall, they're pretty good. There's some work that needs to be done in terms of figuring out the right stat analysis to accompany the design. So please continue to review those in the screencast that I created for that. And also type 1 and type 2 errors and the different validities and sub-facets to those that contribute to each. Definitely review those, and I'll have more to say about that here coming up. Okay, so the first question, remember this week was RDD, and one advantage and one challenge of the design and what is its purpose. So most succinctly, the purpose of an RDD is to strengthen causal inferences when RA is not possible or it is not a good thing for some reason. And so that is a possible advantage to this design as well. So it's okay if the purpose and the advantage were kind of stepping on each other a little bit in this question. But basically what it does is it allows us to assign half the people to the approximately half to the intervention and half to not get the intervention, but we can do that for the most needy individuals or the ones that our client wants us to have in the intervention. So whereas normally that would be a terrible confound with the RDD design, it is actually supposed to be that way. So it really is cool. It mimics a randomized control design and basically takes care of all the threats to validity that a controlled experiment does. So the advantages to that are, again, controls for most validity threats, including regression to the mean and almost every other one that we can think of, especially the internal validity threats. The most needy people can get the intervention that they need. And it can be easily combined with other quasi-designs and random assignment designs. So one we talked about in class was the idea that when people are near the cutoff on either side, they can be randomly assigned by coin flip to either group, and that would be a randomized control in the middle, and then have the intervention on one end and the control on the other end. And as long as there are enough cases in each of those 3 different sections to estimate a regression line, then we're good to go. Possible disadvantages to this design. We need an appropriate assignment variable or pretest variable that has lots of variance. And we need to adhere to the cutoff very carefully and precisely and have no exceptions to that. And so those are 2 of the biggest disadvantages. I guess another one would be that you need at least 200 to do justice to this kind of design. The second question asks about the cutoff score and when it's likely to be violated and issues that come about as a result. So first, participants can manipulate and fabricate their results on the cutoff. If they know what the cutoff is and the intervention is desirable, then they may be able to fake their scores in some way to be able to get into the intervention or out of it, as the case may be. Also, experts, administrators, physicians, etc., whoever we're dealing with, they may want to use their expertise to assign people to intervention instead of the cutoff. And so if we're going to use this design, the cutoff has to be absolutely adhered to. And so that's where the RA in the middle, if we take a third in the middle, that's kind of a lot. It's hard to estimate the line on the ends in that if it's a third, but if it's a little less than a third and you can get just a little space around that cutoff, to where if we have people whose scores fall into that range, then they can be randomly assigned instead. That's a little bit better. And administrators may be more comfortable with that approach because then they're not using their expertise to override the cutoff, and if people are very close, then it's a 50-50 chance. There's treatment crossover where people who are assigned to the intervention, who are over the cutoff, whatever the case may be, actually don't get the intervention and vice versa. So that could be an issue as well. So that's called treatment crossover, and that was discussed in SCC. And that can create a fuzzy, just like the administrators overriding the cutoff, that can create a fuzzy RDD. And remember, a fuzzy RDD is not a good one because we want a very crisp line to be able to estimate the break that we saw in class when we did it in SPSS. All right, and finally, attrition, particularly if the intervention causes the attrition, if the intervention is very difficult for people to stick with, and so they drop out or something like that, or if they're in the control group and they get discouraged and they drop out for that reason, then that's a particular issue. So we want to have attrition that is not intervention correlated or treatment correlated, and we'll learn more about attrition later in the class, but attrition in any design is a problem if it is treatment correlated in particular, and it can cause inference issues because we won't know how the people who stayed in differed from the people who left, and if that was causing us to make an error in our judgment as to whether that intervention was having its desirable effect. All right, number 3, whenever you don't find an effect that is really there in the population, this is a type 2 error. And usually type 2 errors are caused by a construct or a stat conclusion validity issue, sometimes external as well. But for this one, stat conclusion should have been probably at the forefront, I would say. So if you don't find an effect that you really expected to see, there are probably some reasons for that. So it could be unreliable measures. It could be range restriction, within group heterogeneity. Remember, we talked about that in class. That's with too much within group variance that creates a large error term, and therefore we don't have the precision to pick up the effect. We could have a violation of the assumptions of our stats tests. That could also cause type 2 error, in fact, oftentimes does. And for construct validity, there could be some issues going on, such as treatment diffusion. So if people between the groups were talking somehow to each other, and the people in the control group were getting some of the intervention, then that would wash out any differences between the groups, or some of the difference at least between the groups that we would expect to see. Compensatory rivalry could be at play, where the control group was bummed that they didn't get the treatment, so they respond on the DV in the same measure or higher than they would normally, and they start to approach the intervention group in terms of the DV. All right, so there are other ones that could have been correct, I'm sure, for this one as well, and Krista and I definitely consider all other reasonable responses, the TA and I, when we're scoring these. And finally, number 4, there's this matched design, and that is that the students all participate in the program and they all were measured 3 times prior to the intervention and 3 times after, and that entails a repeated measures ANOVA design or a multi-level model design. The multi-level model is better though if you have more observations. So this had only 6, 3 prior and 3 after. Usually with an MLM we would like 10 or some would say a 30 even. And so a repeated measures is probably the best answer, but I will definitely accept MLM as well because a lot of researchers still use it even when they're way under the 10 or the 30 mark. And so that's just a basic, I think, experts kind of disagreeing a little bit and not having a strong consensus on power for MLM. MLM is fairly new still in terms of a stat analysis that hasn't been, doesn't have a very long track record in comparison to other kinds, like a repeated measures. ANOVA definitely has a longer track record, and so the experts are still kind of figuring all that out in terms of power and when it's appropriate to use it. So Just know that they both could be used. And then finally, some plausible validity threats for this. Many are possible, especially internal ones like instrumentation threat, maturation, testing threat, when we're measuring students 3 months prior to the intervention. They could get an idea of what bullying is and that they maybe shouldn't be doing it, and so they could be changing their responses over time. And finally, a history threat is also possible. So something may have happened externally, an event in time that coincided with the intervention time, but it was not. But that event, that external or that history event, was the real thing that caused the change, and not necessarily the intervention, or not necessarily fully the intervention that made that change. And of course, there are other responses that I'm sure are reasonable for that one. I can't think of any at the moment, but as the TA and I are going through them, we will definitely consider reasonable responses for that are that you have evidence for and that are explained well. So. All right, well, I just want to encourage you again to keep up the good work. I think class is going very well so far. I've enjoyed listening to how your progress is with your projects, and I will see you in class next week. Thank you.